Hello, everybody. Again, what would you say to a sneak peek at some final exam problems? Stay tuned. Hey there, I'm Mark Noldy. I've been teaching high school math for almost 25 years now, and I just show students how to do tough problems that we all struggle with, that I struggled with when I was in high school. Here's a trigonometric equation that I think for sure is going to be on your final exam. I know I put these on my final exam. So this one requires factoring. It's also going to require, I see, an identity, right? Pythagorean identity. So let's go through and I'm going to subtract everything on the right-hand side, move it to the left-hand side. So 2 minus, well, first I'd have negative 2 sine squared x. Let me do that. Then minus cosine x. Then I'm going to subtract this 1 on each side. So 2 minus 1 is 1. So far, so good? Yes. All right, so this is what has to become 1 minus cosine squared x. Because we're working at test speed here, I guess. And that's still being multiplied by this negative 2 minus cosine x plus 1 equals 0. So let's distribute this negative 2. So negative 2 times 1 is negative 2, and negative 2 times negative cosine squared x is cosine squared x. We have to be careful with our signs here, because one small mistake with those signs can send us reeling. So let's write this in descending order now, and we can factor it. Look at me, I distributed a 2 but didn't write it. So I have 2 cosine squared x minus cosine x plus 1, no, minus 1. Because when I combine this negative 2 and this positive 1, we get a minus 1 here. So I'm going to go ahead and factor that. That's 2 cosine x. The only factors of 2 cosine squared x are 2 cosine x and cosine x. And the only factors of negative 1 are 1 and negative 1. So one of these has to be positive and one of them has to be negative. So the reason why, of course, this one is negative is because my outer terms become a negative 2. My inner is a positive 1. So that adds up to the negative 1 cosine x here. So now I know I've done that right. So zero product property. If this times that is 0, then this is 0 or that is 0. So let's go ahead and separate that out. 2 cosine x plus 1 equals 0, or the cosine of x minus 1 equals 0. All right, I'm going to slide so I don't erase by accident. And let's see, solving this for x, I have cosine of x equals negative 1/2. So that gives me what? X would have to equal pi. Now check that, make that 2 pi over 3, and then 4 pi over 3. So where do those come from? Let's check this out real quick here. Unit circle. If I come over here in my unit circle, that's going to leave me 60 degrees here. I know that this is 60 degrees here. This is 60 degrees here, because the ratio is going to be, this terminal point is negative 1/2 and 3/2. I should have my unit circle with me because I'm going by memory. So the other place that cosine's negative is down here in quadrant 3. So this would have to be negative 1/2 also, but it would be a negative 3/2, right? Because this is this y coordinate, the sine of this angle is 3/2, so sine's negative down here, so this just gets changed to a negative. So that's where these angles are coming from. This being, let me switch to red, 120 degrees is equal to 2 pi over 3. And all the way around here, I'll switch to red. All the way around to here, that's going to be 4 pi thirds. All right, because we went 60 degrees past 180. So this would be, let's see, 180 and 60 would be 240 degrees. Okay, I'm not good with my degrees, I guess. I'm better with my radians, because that's usually what we do. This one's easier to do. Cosine of x equals 1. So again, unit circle. This is the point 1, 0. So that means that the cosine of 0 is 1, and the cosine of, or the sine of 0 is 1. So that's the only place on the unit circle. This is negative 1 over here. These are 0 and 0. So this is the only place. Now, let me write down that x equals 1. I have to get my correct color back again here. So x equals 0, rather. Cosine of x is 1. Depending on what your range is, you can stop right here if the problem puts you on this domain, rather. So if your domain is just 0 to 2 pi, you're done. If they want all of these, well, then you're going to go, let's see, we'll use the blue again, 2 pi thirds plus, I can add 2 pi and just revolve n times. N could be positive or negative. For the red one, we would be looking at, well, 4 pi thirds, and that would be plus 2 pi times n. So as many times as you wanted to revolve, this is what I'm talking about. From here, 1, 1, 1. You always end up at this coterminal angle. So there are technically infinitely many problems there, but often in my final exams, I let students use the domain of 0 to 2 pi. All right, so there is the first example. All right, so here's one where we're using, going to use an identity here. And that identity, this is the granddaddy of them all. I don't know why, but I see this on a lot of final exams. I put it on a lot of the final exams. The college I teach for has it on their final exams. So, and that is a double angle identity. So we'd use this double angle formula for sine of 2x becomes 2 times the sine of x times the cosine of x. Then I'm going to move this to the left-hand side. So that just becomes minus cosine x. And by doing this little maneuver here, we have a common factor of cosine that we can factor out. Or undistribute, if you prefer. It's not really a word, but I use it all the time because people understand it. All right, so I just undistributed this. So if I went back, I'd say cosine times 2 sine x. Well, that was my 2 cosine x. And cosine x times minus 1, that was my minus cosine x. So if this times that equals 0, either this equals 0 or that equals 0. So let's set that up. Cosine of x can equal 0, or 2 sine x minus 1 can equal 0. Getting down towards the bottom. So if cosine of x equals 0, okay, looking here, unit circle, where is the x coordinate 0? At the top and bottom of the unit circle. So this would be 90 degrees or pi halves. We usually answer these in radians. So that would be pi halves. And it is also 0 down here at 270 degrees. But we usually call that 3 pi over 2. So 3 pi over 2. And again, we're going to say we're on this is our range. We restrict our range to just one revolution around the circle, unit circle. So this becomes sine of x equals 1 or sine of x equals 1/2. So the sine is the x coordinate on the unit circle. So here's my unit circle. So right here, I would have 1/2 and then root 3 over 2 for the sine. And then over here, sine is also positive, so it'd still be 1/2, only this would now be negative because we're left of the y-axis. So both of these are 30-degree angles right here. So the angle I'm looking for my answer is, forgot my x, is that x would have to be 30 degrees or pi sixths. And if I went all the way, let me get the red, if I went all the way over to this angle here, this is pi sixths as my reference angle. So the actual angle, the red angle, is 5, oops, I wrote 5/6 instead of 5 pi over 6. So there is another equation, and again, keep in mind there's always going to be a little bit of a wrinkle. So you're either going to have to factor or use an identity or a combination of both, like on that first example. So there's the end of example 2. So for example 3, I'm switching to this. This is actually the textbook that I use in my classroom. And the reason I'm switching is because the final exam problems usually have like a picture with them. So this was one that is a good picture, and I could see as a final exam problem. So it's about the length of a tunnel. So the tunnel is built through the mountain. To estimate the length of the tunnel, the surveyor makes the arrangements shown in figure 3. That's over here. So use the surveyor's data to approximate the length. So this is the problem worked out. So I will quick work it out for you. So there's a couple of different times when you're going to use law of cosines, and this is one of those times. So law of cosines. Let me go with red ink. So law, whoops, I better switch the width of my pencil too. I notice that's a pretty thick ink. So that's more gooder. All right, so law of sines. I'm sorry, I said sines. This is law of cosines. The reason we know this is because we have a side, two sides, and an included angle. So that's SAS. Remember all those from geometry class. Also, if we have 3 sides, we would use the law of sines. So anyway, this one is straight up law of cosines. So this would be side C, I suppose. This is side A, because it's across from the A. This is side B, because it's across from the B. So anyway, here's my formula. C squared equals A squared plus B squared minus 2ab times the cosine of c. So these are, it's kind of easy to remember once you see that whatever side you're solving for, that's the angle you need over here. And it looks a lot like Pythagorean theorem, a squared plus b squared minus 2, and a and b are these two letters here. So when you switch the letters, like if I was solving for a, this would be a c squared, and that would be an a. So by any event, let's go ahead and set this up. So I have, let's see, 212 feet squared plus 388 squared plus minus 2 times 212 times 388 times the cosine of 82.4 degrees. So, which is given in the picture here. So at this point in time, I just have my students pull their calculator out, and they can just type all of this straight away into the calculator. Naturally, make sure that you are in degree mode. If you are not in degree mode, you're going to get funky looking answers, because 82 radians is a lot of radians. So type this all into your calculator. Coming up with 173,730.2367. So that's how many square feet. So you need to take the square root, remember, to solve for this. This is the probably most common mistake that I see made, and I make it myself sometimes when I'm making an answer key or something, but I forget to take the square root here. So the square root of this is 416.8. I'll go with just 0.8 feet, because that's one more decimal than is in the picture. If I had to figure out an angle, I'd go with 2 decimals, right? Just law of rounding. So your final answer here, using the law of sines, or cosines, I keep saying sines, cosines, is 416.8 feet. So the reason, again, I switched to the text is because pictures are very commonly used on the final exams that I use for the college that I teach for through my high school. It's a dual enrollment course. All right, so that was 3 examples. I think for the next, because this is getting a long video, the next time I do my Tuesday morning video, I will show 3 more examples, trigonometric related examples that I know for sure are going to be on your final exam. So here's your question of the day. What's the hardest final exam that you have ever taken? Let me know in the comments down below. Hope you like that sneak peek into the final exams. Don't forget, math's not a spectator sport. You still have to do your homework. The only way to learn math is to do math.